welcome again to my channel. Today also we are going to be solving another LeetCode question, LeetCode number 200, and it is marked medium. So the question says that we will be given an input of a 2D binary array, 2D binary grid, right? The array will only contain ones and zeros. Here ones represent land, as you can see, and zeros represent water. So basically we have to count the number of islands formed by ones and return the count. Let's see an input. So this is an input, this is the input, right? I've made it into a table. So if we look here, we'll see that these four ones are grouped together, so this will count as one island. This will be a second island and this will be the third island. Now you might think that this as a whole can be an island, right? But we can only connect lands or pieces of land horizontally and vertically, right? We cannot connect them diagonally. So that's why this is one island, this is another, and this is the third one, right? So the answer for this input will be 3. How are we going to solve this question? How are we going to approach it? It will be pretty simple approach. Is a pretty simple logic. We'll just run a 2D for loop, right? One for loop inside the other will traverse the whole grid, and whenever we encounter one, we'll increase the count by 1, right? So let's say initially we have a count of 0, right? We'll start the traversing from 0 0, that means from this cell, right? And in this cell itself we encounter a 1, so that means we'll increase the count to be 1, right? We'll increase the count. Now if we keep on traversing, so we reach this cell, the next cell will be this one, right? We'll encounter another one, but does that mean we'll have to increase the count? No, because as I said earlier, this whole group of ones are is a single island, right? So that means we'll have to find a way to basically remove this one, this and this one together, right? And for that we'll be using BFS. So whenever we encounter a 1, we'll run a BFS uh, algorithm, and which will remove all the related ones and replace them with zeros. So that means this will be removed and they all will become zeros. So this will become a 0 and these all will become zeros. Now when we move on from here to here, we'll encounter a 0, not a 1. So the count will remain as 1, and we keep on traversing this way, this way, this way until we reach this cell and we encounter another 1. Here also we'll remove this 1 and replace it with 0. Sorry, we'll remove this one and replace it with 0, and we'll increase the count here. So this will become 2, right? And in similar fashion we'll encounter this at the last, this one in the last, and we'll remove these and the count will increase to 3, and these will be replaced here. Right, and we'll finally return 3. So logically it's a very easy question, right? Let's go to the implementation. Let's write the code for this. First of all, let's find the length and like the number of rows and number of columns for, so that we can run the 2D loop, right? So here m is the number of rows and n is the number of columns. right? We'll run a loop. I 0, I will move till m I plus plus. Inside this there will be another loop. And we'll check here if grade of I j is equal to 1. That means did we hit a land piece, right? If we did, we'll first of all remove this to, or you can do that in the BFS itself. So we'll just run the BFS function and we'll pass I and j, right? And we'll increase the count. Actually here we've hit a land, so we'll increase the count, right? The number of islands, we'll have to take that as well. Count initially will be 0. Now we have to write the BFS function. Okay, so let's do that. We'll take I and j, or let's name it as row column int. It will return nothing, right? Now let's initialize the queue which is used in the BFS, right? So queue equal to, it will be these row and column pair itself. So it will be an array of 2 ints, right? And initially it will have the row and column that we pass, and we'll say grid of row and column which we pass will be equal to 0. That means we'll mark it as visited so that we don't go into this cell again, right? Now for length of queue greater than 0, we'll run this loop as long as there are items in the queue, right? That's how BFS works. Now we'll get the first item from the queue, so current equal to queue of 0, and we'll remove that item from the queue of, and we'll slice that. Now we'll run a for loop to do what? Let's see. So imagine I'm here in this cell, right? I want to go to those cells, those surrounding cells that are 1. That means I want, since I'm on land, I want to go the nearby land cells, basically the ones, right? So where can I go? I can go right, I can go down, I can go up, or I can go left. In this case we of course cannot go up and left, but you get the idea, right? So let's imagine I'm here. Where will I check? I'll check up, down, right and left, right? So for that we need to have a directions variable. So let's initialize that. Bar direction, it will be a2 of int 1, 0, 0, 1, minus 1, 0, 0, minus 1. So what is this? This is basically what we'll add, right? So that means the first number represents the row and the second number represents the column. So let's say we want to go up. Let's imagine we are here and we want to go up. Going up is a change in the row number, right? So this is the first row and this is the 0th row. So if I want to go up, I am essentially moving from the first row to the 0th row without any change in the column number. The column is the same column, right? When we are going up, so that means we have to subtract 1 from the I, or from the row number, right? We have to subtract 1. So that is represented here. So when we use this is saying we are going up. This says we are going left. This says we are going right, and this says we are going down. Okay, so let's use those. We'll run a for loop. So basically for each particular cell we'll say that we can go in all the 4 directions, right? So for, let's go d range direction, I'll say new row will be current row that we have, or current of 0 that we have, because the first number represents the row, plus d of 0, because as I said the first number is represented as row. So to find the new row, we'll add the current row and the new row that we want to move to, right? Like 1 or -1. New column will be current of 1 plus direction of 1. Now we have to check if the new row and the new column numbers are valid or not. If new row is greater than equal to 0, it should be greater than equal to 0, right? Both new row and new column greater than equal to 0, and new row should be less than m, and new column should be less than n, and also the values at these new row and new column should be equal to 1. Why? Because as I said, we are only looking for the nearby land pieces, not water. Zero means water, right? We don't want to go into water. BFS should only change 1 to zeros, not zeros to 1, right? So we are trying to find as many connected ones as possible. So that's why we are checking that the new value, that the new cell we are going into should be a land piece as well. If it is so, we'll change it, we'll mark it as visited. So grid of new row, new column will be equal to 0. That means we have visited this cell, and we'll append this. Q equal to append Q new row, new column. We'll append it to the queue. Why do we append it to the queue? Because imagine I'm here and I move to this cell. From this cell I also want to move to this cell, right? That's why we are appending every possible cell. When I'm in this cell, I'm appending this and this. These two cells I'm appending, and from these two cells I'm moving into this cell, right? So that should be the BFS function. We are changing ones to zeros, right? And we're increasing the count every time we hit a new island, right? So then at last we'll return the count. Let's try to run this, and it is working. Let's try and submit it, and it is working. Cool. This was a pretty easy solution if you knew the BFS code, how BFS works. Basically we append every new item to a queue and keep on appending items though that meet our criteria, right? So in this case our criteria was that we wanted to traverse to only the land cells, the basically ones, and convert them to zeros, and keep on doing to the nearby cell. So we were appending every new cell to the queue, and this loop ran um, as long as the queue had items. The length of queue was greater than 0, and even after that if you hit a new one, that means it was a new island, so we'll increase the count, and again same do the BFS, so the connected ones will get converted to zeros, right? And in the end we'll return a count. So that was it for today. Hope you understood something, and I'll see you in the next one. Subscribe if you like. Thank you.